I just saw this video with almost 300,000 views that is very misleading. This guy talks about two cars, a blue car and a red car. The blue car is doing 70, the red car is doing 100. He's saying with the same mass and the same coefficients of friction that basically these two cars travel down a road, one of them stops just before hitting a tree and the other one continues to hit the tree, and talks about what speed it hits the tree at. I think he went to some driving class or something like that, and I think they tried to maybe make him drive slower because he probably crashed his car 1,000 times. So I'm just going to give you a little correct mass. So in his example, he talks about a red car and a blue car. Red car is doing 100, blue car is doing 70. Says that the red car hits its brakes on a roadway and stops before hitting a tree. So therefore its kinetic energy is at 0. It would have no kinetic energy because it hit the tree and stopped. He then says that the blue car continues and hits the tree traveling, no, I'm sorry, he says the blue car travels, hits the tree and stops. Its kinetic energy is 0. So this one's 0. But he says the red car hits the tree, and what's its speed and velocity when it hits the tree? And he comes up to a number of 71.41 miles per hour. But his math is incorrect. The reason why is ultimately he calculates that this one vehicle, the red car, has a value of 10,000 in kinetic energy when it crashes. Wow, this is horrible. Kinetic energy. And then he says that the other car has 4,900 in kinetic energy. And he subtracts those values and he comes up with 5,100. The issue is that if the red car still had 5,100 in kinetic energy left, and you're equating that to be 71.41 miles an hour, then the same value would have to apply to the blue car. And you would have to say that the blue car lost 4,900, but it would still have negative 5,100 in kinetic energy left, right? So therefore it wouldn't just stop before the tree, it would move backwards because it still has kinetic energy left. So let me just give you a perfect example. You're looking for your speed as a constant. What was the speed of these two vehicles to begin with? What you're going to do is you're going to take the known speed of the vehicles and you're going to square root that. Then you're going to subtract it because you're going from the tree, moving backwards to what was their speed before they hit it. 30 is a known constant, so it stays in there. The distance, he didn't give one, we'll make one up and we'll just argue and say 100 feet. And then we're saying that the coefficient of friction, not the mass of a vehicle, which is kinetic energy, but the coefficient of friction is the amount of friction that your tires have against the surface of the road. Different roadways have different surface frictions. Different vehicles have different weights, so you have different coefficients of friction of gravity pushing onto the surface. That's why trucks take a longer distance to stop. Lighter cars take a shorter distance to stop. They could be at the same speed, but that heavier truck is pushing against the road harder, and therefore it has more inertia to keep on sliding. So what I broke it down to is that we know that when the car hits the tree, it stops. So it would be doing 0 miles an hour. So if you squared 0 times 0, you'd get 0. Then we're going backwards because what we want to do is reduce the speed, right? Because he's going down into that tree. Actually, no, I take that wrong. My math is wrong. It's actually positive because we're at the tree going backwards. So there's going to be an increase in speed. Either way, the 30 is a known constant times the distance that we're going to make to be 100, and then we'll use the same coefficient of friction. So if we said that this vehicle hits a tree at 0 miles an hour, has a coefficient of 30, it's 100 feet, and the friction is the same, we're going to get a number of 1,500. What you're going to have to do is square root that 1,500, and you're going to get 38.72 at 100 feet, which means if we go from the tree and we move backwards, this number is going to be a positive plus. So before it hit the tree at 100 feet back, the one vehicle, which would be the blue vehicle, was traveling 38.72 miles per hour. So that's your blue vehicle. In the same contrast, you would have to then say, based on his example, that if this vehicle came and it started at the tree where it hit it at 71.41 miles an hour, you would have to take 71.41 and square root that and get 5,099. You would use the same 30 coefficient, same distance, same roadway surface friction, and you would get on that 6,598, because you would get 1,500 and you'd be adding this. Then you square root it and you get 8123, and that's miles per hour. So in reality, these two cars, where he's saying one's doing 70 miles an hour and the other one's doing 100, this one's 30 miles an hour faster. In this same example, the one blue car would be doing 38 miles an hour. The red car at that same distance will be doing 81 miles an hour. This car, the red car, is going faster. It's positive, it has more value. So in the same example, you can't say in kinetic energy that they both had 0 and hit this tree. If they both had 0, they would have no energy. So just as a correction, I had to throw that video up there because the math is wrong. You can't sit there and say that one vehicle has 10,000 units of kinetic energy and subtract that from another vehicle and come up with 5,100 units of kinetic energy, because then this vehicle wouldn't be at a stop. He would be a negative 5,100 units of kinetic energy. That's just math, kids. You can't argue with that.